Alright guys, this is the second video of our unit on proportions and proportional relationships. And today's video is called, Is It Proportional? You should be on page 56. The date that you should put on is November 6, 2013, because that is the day the video was assigned. Please make sure you are numbering your pages and putting the dates correctly so you don't lose points on a notebook check. And our objective for the day is I can recognize proportional relationships in graphs, tables, and equations. That means I should be able to show you a graph, show you a table, show you an equation, and you should be able to tell me automatically, yes, it is a proportional relationship, no, it is not a proportional relationship. And there are a couple key things you need to look for in each one of these situations to decide if something is proportional. So still on this same page, let's talk about graphs. When we have a graph of a proportional relationship, it's going to look a certain way. So a graph of an equation of a relationship is going to be on an XY axis. We've talked about plotting points on an XY axis, and I know you've done this in previous years. You have little dashes on your lines, right? Okay. So if we have a graph that is a straight line, so we can't have any curvy lines, that won't do. If it has a straight line and it goes through the origin. Origin might be a fairly new vocabulary word for you, but it's just the point 0, 0. That's just right in the center of your XY axis. So you have a point and the graph is you have a graph and it's a straight line and it starts at the origin and then goes out, maybe up that way, maybe down that way, maybe right about in the middle. Then it shows a proportional relationship. So let's say on the other hand, we have something that looks like this. Oh, hang on. There we go. It is a straight line, so that has half of the requirements, but it does not go through the origin. That point 0, 0 right in the center of the graph. So this would not be a proportional relationship. Not. This one is. Okay? Please draw these two different graphs in your notebook so that you have a reference for what is and what is not a proportional relationship. And I'm going to just show you one more. Let's say I have a graph of something and it does go through the origin, but it kind of goes like this. That is not a proportional relationship, once again, because it might go through the origin, but it isn't a straight line. You have to have both, a straight line and the graph hitting the point 0, 0. Okay, so in graphs, pretty basic to figure out whether it's proportional or not. We're going to go on to the, oh, nope, not yet. I want to show you this really neat graph that I found. This graph talks about, people ask me all the time, why does this matter in the real world? Well, in the real world, people use graphs and charts to try and understand how things work. So this is a graph that talks about earnings or how much money somebody makes in relationship to the number of hours that they work. So we have 4 different examples here. We have Bill Gates, who you probably know is a very, very rich man, a lawyer, a plumber, and an entry level. That's somebody working at minimum wage. Okay, maybe working at McDonald's or working, I don't know, anywhere where they make minimum wage. As you can see based on this chart, Bill Gates' line, this purple line, is very steep, okay? It goes up pretty quick. He's making $451 in just 1 hour, so a 40-hour work week for Bill Gates makes him approximately $17,000, $18,000 in 1 week. A lawyer in 1 week makes about $12,000 right here. A plumber, and that's a good lawyer, by the way. A plumber would only make about $2,500 in one work week, working at $60 an hour, and that's actually a very well-paid plumber. An entry-level person working at $6 an hour minimum wage with no training or degree or anything like that. Look at that line. See how that's a flat, straight line right there? It only goes up an itty-bitty bit. They're making maybe $100 in a 40-hour work week. Okay, maybe $150 once you take taxes out. So I say all the time, I talk about, when you go to college, what career you're going to choose, all that kind of stuff. This kind of graph gives you a real nice, good snapshot of how your earnings, the money you make, depends on your training. No training at all, you're at this very shallow line. You're not going up very fast. Training at like a skilled trade like plumbing or construction, you can make a fair amount. You go to college and you get a bachelor's degree and a master's degree or a law degree, you're going to be making a lot more money. Okay? So let's go on to the next page. That's my little, hey, go to college promotion. So now we're on page 57. It is November 6th still. And now we are going to find in a table how to figure out if a relationship is proportional. So if each, and this is kind of a mathy definition, so just bear with me. If each ratio of one variable to the other variable is equivalent means equal, then the relationship between the two variables is proportional. Okay, let's try this in like real person speak now. Okay, if I have this table and I have a whole bunch of x's and a whole bunch of y's, I'm looking for the relationship between x and y. If it is the same relationship for every number, if they are equivalent ratios, then I'm good. So 3 to 6, I can make a fraction like that. And then 4 to 8, I can make a fraction like that. If I use my test that we learned about the other day for finding out if two fractions are proportional, I can use cross products. 6 times 4 is 24. 3 times 8 is 24. It's not a bad idea to try this with some of the other numbers in your table just to double check that all of them are proportional. So let's try 3 to 6 and how about 6 to 12? Cross products gives me 36 and 36. So yep, that is proportional as well. Let's look at an example that is not proportional. I have an XY chart here as well. Let's make a fraction 2 to 8. And then let's do 3 to 10. Cross products gives me 20 and 24. So I know right away that this is not a proportional relationship. In the first two fractions I tried, they are not equal. So it is not proportional. Okay? Last thing we're going to look at is in an equation. An equation is something like a y equals 3x plus 2 kind of thing. These are going to be much, much more important as we move on throughout the year. So in an equation, if a variable, this is a mathy definition again, I know, is the product means multiplication, of a constant, that's a plain old number. I totally spelled plain wrong. Sorry about that. And another variable, it is proportional. Okay, let's break that down into something that makes a little bit more sense. I have this sample equation here. If a variable, for example, y, is the product, multiplication, these two things are multiplying, of a constant, k represents a constant. You might have seen a question on an iReady test that you've taken about finding the constant of proportionality. Well, that k just stands for the constant of proportionality. So it could be any number. It could be 3, 6.7, 1/2, whatever. And another variable. So a different variable than the one we started with. So we started with a y. We have our constant of proportionality. And now we have a second variable. So these are really easy to figure out, guys. Let's take a look at this first equation. I have y plus x equals 7. That looks nothing like this standard form of a proportional equation. So this one is not proportional. This one is a little tricky because it looks like it might be proportional. You have a constant with a number, you have a variable with a constant multiplied by a variable. But notice my two variables are the same. Okay, therefore it is not proportional. You have to have different variables. So y over x equals 3. This one I threw in there to really kind of trick you, because you can do something really awesome with this equation. You know how we've been learning about algebra? We have y over x equals 3. We can move this to the other side. And if I'm kind of freaking you out, it's okay. So I'm going to multiply both sides by x. Those are going to cancel, and I get y equals 3 times x. That is a proportional relationship. Crazy, huh? This one clearly is not, because it has this extra added number over on the side. I have y equals 2x. That whole part is fine. But then this plus 1 means that it's not proportional. And finally, I have this, which is kind of a classic proportional relationship equation. Y equals 3.5 times a variable x. All right, your reflection. I want you to look at this table, and I want you to tell me, does this table represent a proportional relationship? And once again, the most important part of your reflection is why. Give me a specific reason why it does or does not represent a proportional relationship. All right, guys, have a good one. Bye-bye.